so this is the physical science course. So this is chapter 1. And what we're going to start with is the scientific method. So this kind of follows along with the order that you'll see in the PowerPoint video on YouTube that's posted. So we'll start with scientific method, and then we'll move into significant figures, and how to add, subtract, multiply, and divide using significant figures. And last but not least, we'll get into scientific notation. So starting with the scientific method, this is the flow chart that you might have seen if you've looked at the PowerPoints at all. So the scientific method, it's an organized approach to solving scientific problems. So when a scientist sees something that they want to know the reasoning behind it, they generally follow this flow chart to figure out the why behind it. Okay? So it always starts with an observation. So what an observation is, any of your senses. You know, if you see something, if you smell something, if you hear something, okay, that's a hint that it's an observation. The example I like to use is Newton, right? He saw an apple fall from a tree and wondered why. Okay, so that brings us to the question. Why did it fall? Okay, from there, you come up with a question, you need to answer it. So that's what the hypothesis is. It's a way to answer that question based off of your previous knowledge. Okay, so it's not supported by fact yet, it's just why you think that happened, your explanation for it. Once you have an explanation, you can then run a series of experiments to help support or disprove your explanation. Okay, so you will run the experiments, you'll analyze the data. If your experiments and data support your hypothesis, you're going to go over here to a theory. So a theory and a hypothesis, they're related to each other, right? Because the hypothesis is your explanation, your common sense way of explaining away that observation. And the theory is just a hypothesis, but now it has the fact behind it. It has the data, okay? You can have supporting data to prove it. Sometimes, however, your experiments and data don't support your hypothesis, and that's when you have to come back up here and start again. Okay, so what I wanted to put to use today is the questions you're going to see most often dealing with the scientific method are definitions for one, so you'll want to review the definitions of scientific method and each of the steps, which I have on the PowerPoints. But also, I might give you a situation like the ones here. And what I want you to be able to do is tell me what part of the scientific method is being used here. Okay, so let's look and classify these situations with one of the steps of the scientific method. So the first one, what doorknob in school has the most germs? That's appropriate for right now, right? So if I were to say, what doorknob in school has the most germs, what part am I applying?
A question.
Question. I mean, the question mark tells you, right? So when you're trying to classify, you're looking for clues to help you figure out what step. In this one, it's a question mark, so this is going to be question, the question part of the scientific method. This next one, so I'm from North Dakota, is why I put that in there, but noticing that it's hotter in Arkansas than it is in North Dakota. What step would that be?
Observation.
Observation, what tells you that?
Because you notice.
You're just noticing it. You're feeling it. It's one of your senses, right? You feel that it's hotter here. Okay, so if it's any of these deal with a feeling, taste, hear, smell, touch, okay, that would be an observation. So this one indeed is an observation. You haven't come to any conclusions yet, you just noticed it. Okay, that's the first step. Your next step would be, why is it hotter, right? Asking the question. And you go from there. So number 3 here, assuming that leaves change color in the fall due to temperature. So we're assuming something. It's not a question, because you're not asking.
Or hypothesis.
So it's a tough one. And the key here is this assuming part. All right, so what I was trying to get at here is, it's not yet data because it doesn't say, there's no proof here, okay? It's not experiments because you aren't saying, okay, so I set it up in these different temperatures and it, these leads got color before these ones at this temperature, that would be the experiments and the data. This is indeed a hypothesis because you're not saying they do change because of temperature. There's proof behind it. You're just assuming it. This is your initial explanation. You're saying, I think they change because the temperature fall. And that's not the only reason, actually. So the assuming part tells you that this is a hypothesis. So if you ever see the words assume or I think, that would say lead to hypothesis. All right, let's do the last one. So if you put grass seeds under a green light bulb, one under a red light bulb, and one under no light bulb, what do you think you're setting up there by doing that?
Experiment.
You're setting up an experiment, okay? You have conditions, specific conditions. I'm taking one and applying specific conditions. I'm taking another sample and applying a different set of conditions, and then a third sample, yet another. Okay, so this is describing an experiment. Now I want to talk about this one further, because with an experiment, you need to know about what a control group is. Okay, so I'm going to erase this top part here. And this is all captured on video, so you can refer back to these examples if you forget them. But I want to expand upon this one, so I'm just making room. So if this is your experiment, you need to not only recognize the situation of an experiment, but you need to know the term control group. So with experiments, there's a control group. And what a control group is the placebo group, right? Whenever you have drug testing, for instance, and say you're drug testing on mice, you give one group of mice the placebo with nothing in it. You give the second set, let's say 5 milligrams, and you give the third set 10 milligrams, and then you study the differences between them. So the control group is the one with the placebo, right? So you need to be able to recognize, given a set of conditions, which group is the control group. So if I was looking at this experiment, which group is the control group? Is it the green light bulb group, the red light bulb group, or the no light bulb group? The third one, the no light bulb, that would be your placebo. They're not getting anything, they're not getting the drug, right? So in this case, it's going to be no light bulb, because you need something to compare it against. You can't just put conditions for everybody, because you don't know what would happen if there was no conditions. So you need that to set the tone for your experiments, for your data analysis. All right, are there questions on scientific method? So I was just trying to show you, based off of this flow chart, how you're going to use it when it comes to questions and homework and on the exam. Okay, what types of questions, how it's going to be applied for this course.